As I'm drawing the rest of this diagram, somebody name that line there for me. Line EH would work. Give me something else. Line HE, give me something else. EF, line EF, line FH, line FE, so on, so on, so on. Whole bunch of different ways to name it. Everybody knows that that hits that point right there, right? No, I missed it. Didn't miss anything, did I? All right, the given information this time, they tell us that angle GFH, that's that angle right there, is congruent to angle GHF. GHF, that's this thing. So we mark those. Those two angles have to be congruent. They're have the same measure. We're trying to prove that angle EFG, that's this angle, is supplementary to angle GHF. GHF, that's this angle. And they want us to write a two-column proof. With your two-column proofs, remember you're going to have, what's this column? Statements, good. Reasons, good. Now, even if Bree has no clue how to do any of these, could she get this first one?
Yeah, just give it.
It's what they told you, right? So you write that, and it's gonna, what's the reason over here gonna be?
Given.
Given. Now, where most of you get yourself into trouble when you're doing these two-column proofs, you don't think something through before you start to actually put it down on paper, right? This is just like an English paper. If you go into English and you just start writing your paper without doing a rough draft or a outline or something, you usually get a real good grade. You might get a passing grade, but it's not very good, right, usually. And my writing, I'm horrible at writing, but all the way through college, I did well in English classes or literature classes because I did an outline first, then I did a rough draft, then I did the regular paper, because I knew that my writing was going to be horrible. I don't want to say I did well. I mean, I got above average. Got like B's and everything, even though I can't write worth anything. What can you tell me about these two angles right here? They're supplementary because together they make a 180 in line, right? What do we know about these two angles? They told us they're congruent. So let's make up something. Give me an easy measure. What do you think angle EFG might be? 160. 160? So if we said it's 160 degrees, what would this angle right here in the middle have to be? 20 degrees. What would this angle have to be? 20 degrees. What do you notice about this angle and this angle? They add up to 180, so they're what to each other? Supplementary. Right? Is that going to happen every time, no matter what kind of numbers we pick there for these angles? Yeah. We just picked some random number. Chloe picked 160. Worked out. Could we pick a different angle for, or measure for EFG? Yeah, maybe it's 100. If it's 100, what's this angle in the middle here? 80. What's this angle over here then? 80. What do you notice about those two? They're supplementary to each other. And that's what I mean by thinking it through. Think it out and say, oh, because that's what we're trying to prove. We're trying to prove that this angle is supplementary to that angle. What's the first statement we're going to make? Somebody help me out so I don't have to keep looking back at the book. Angle what? Angle GFH is congruent to which angle?
GHF.
GHF. And how do we know that?
It was given to us.
It was given to us. Now we come over here. What did you guys tell me about angle GFH?
20 degrees.
Yeah, that's what you told me, but let's not throw any numbers in there. That was just for us to think it through. What do you know about that angle and this angle?
It makes 180.
Okay, so that's what I'm going to say next. Angle,
GFH.
not GFH. Yeah, it is GFH. Sorry. Angle GFH.
Supplementary to GFE.
FE. How about if we go the other way? EFG. And the only reason I went the other way, notice I looked at the book, right? Just to see how they named it. We don't want to name it backwards from what they named it, because then that's going to confuse us down the road. How did you know that those two angles were supplementary? And I think did we have something last time, or it might be the day that we had? This is going to be your reason. Linear pairs, that's what they are, right? They're a linear pair, because together they form a line. Linear pairs are supplementary. Now, once we have that, notice what you have right here and what you have right there. Same thing, right? So if this is equal to that, can I take out this angle GFH and put anything in its place? What could I put in its place? Those two are equal, right? So wherever you see one of those, you can take it out and put the other one in its place. So if I rewrite this second statement here, taking angle GFH out, tell me how to write it now. Angle GHF supplementary to what? EFG. What were we trying to prove? Is that what we're saying right here? What property did I use to go from 2 to 3? Substitution property. Substitution property. Is it alright if I abbreviate substitution that way? You can tell that, right? That's far enough out that you can tell what it means. Just don't put like SUBS or something like that. Next question. 23. Solve for X using the given information, justify each step. So they want us to do a 2-column proof on this one. The given information says segment QR is congruent to segment PS, and RS is congruent to segment PQ. It does that. Can't read. I got it right now, right? They give us this diagram. So if QR is congruent to PQ, so that means these two are congruent. And then RS is congruent to PQ. We'll do it. How many marks am I going to put on RS? If PQ's already got 1 mark on it, you're going to put 2 on it? Well, we're trying to say it's congruent to PQ, so what happens there? Now it's only got 1 mark. It doesn't look like they're congruent. So how many should PQ have? 2. Well, then now that messes up these 2. So what should we put here? What do we know, Chloe? They're all 3 congruent, aren't they? So all 3 of those are congruent. What property did we use there to say they're all 3 congruent? 2 different things you could use. Substitution would work. Transitive property. Either one of those would work. Alright, so somewhere we're going to have to say that in there. in our two column proof. That, hey, we know now that QR and RS are congruent to each other also. Well, once we know those two are congruent, what equation can we set up? 2x plus 5 equals what?
10 raised to x.
Alright, and we're gonna use substitution again on that, and I'm just gonna solve it in here. First column again is your statements, and you have your reasons. What's your first statement gonna be?
QR. Put it in
QR is congruent to PQ. Now watch, because this sort of mixes the geometry and the algebra together. How do we know that? It was given, so we write that. Notice, I didn't write the other given in there because how many points you gonna get for those two right there? 2 points, right? And then for the next one, we're gonna get another 2 points. RS is congruent to PQ. How do we know that? That was given to us also. What'd you guys tell me after that? Chloe told us. What'd we know about all of them then? They're all equal. So what other pair can we match up? RS and PQ. What we got?
RS and QR.
RS and QR. So we're going to say QR is congruent to RS. How did we go from 1 and 2 here to get to 3? What property did we use? Substitution property. Substitution property. Now, once we know that QR is congruent to RS, what did you guys tell me? That we could do what? We could set up that equation, right? What equation? Two x plus 5 equals. What did you do to go from 3 to 4? We took out segment QR, right? What did we put in its place? 2x plus 5. We took out RS and stuck what in its place? What property did we use again? Substitution again. Substitution property. You just took out something and stuck something it was equal to in its place. Now, once we have that, what are we going to do next? What do we do first? Get the x's together. So what do we end up with? 5x, good. Plus 5, plus 10. Now we're on the algebra stuff, right? What property are we using in algebra there? Addition property. Just addition property? Gotta make sure you put that of equality on there because we did something to both sides. Now what? Minus 5 on both sides. What's that leave us with? 5x equals 5. What did we use there? So subtraction, property, of equality again, good. Of equality. Are we finished?
No.
5 by 5, what's that leave you with?
1.
X equals 1. What property did you use there? Division property. Equality. We're finished now. What they ask us to do on 23? And justify each step, right? Did we do that?
Yep.
How many points would this be worth on the test? 14. 14 points. Be worth 14 points on the test?
It's not bad. It's a big question.
That's a pretty big question, isn't it? Pretty,
So, like,
quite a few points.
How many of those are we gonna have?
2 or 3. Should anybody miss these first 4 points?
Yep.
So you got 1, 2, 3, 4 points. You've been missing.
Third and fourth.
Now, I don't think you should miss this because if you look here, is it pretty obvious that you use substitution or transitive property because you have PQ in both of them? Yeah. Alright, so to me that seems pretty obvious, but maybe to you it doesn't. You get here, that you know that they want you to solve for x. Should anybody miss this statement right here? Nah, cause you know that you gotta set up the equation, so that's another one, that's 5. Maybe you don't know the reason for that, so we'll say you miss it. Should anybody miss this step? How about this one? Those are all things you should have learned last year, right? Can you get all these 3 reasons right out here?
You
You should be able to, so that's 3 more points. So now you got 11 out of 14 points, I think, too bad. Yeah. And that's just saying, maybe even, let's say you don't get, maybe you miss all 3 of those, maybe you don't know the properties. Then you got 8 out of 14. That's a whole lot better than nothing still, isn't it? And that's not even doing anything.
Still better than 4 out of 14.
Right. So just don't skip over these and give up on them, because maybe you get lucky and get quite a few. Other questions? Make sure you're asking. Still with us, Curtis?
Yeah.
Make sure you ask, because I know this stuff's hard. Right, Bree? Problem 25. Use the figure. Angle 3 is supplementary to angle 2. If angle 2 is 147 degrees, find angle 3. What do you know this supplement means? They add up to 180. So if angle 3, or I'm sorry, if angle 2 is 147, how could we find angle 3?
Use subtract 180 minus whatever.
147.
Yeah.
Borrow here.
33.
3. What's 7 minus 4?
33.
So the measure of the other angle is 33 degrees. Just looking at that picture, what can you tell me about angle 1 and angle 2? This is part of what we're going to do today.
Supplementary.
They're supplementary. What can you tell me about angle 1 and angle 3?
The vertical angle.
The vertical angles. If they're vertical, what do you know about them?
They're
They're congruent. They're equal. How about angle 4? Is angle 4 supplementary to angle 2?
Yeah. No.
It's on a different vertex, right? So you got to be careful of that. A lot of people mess that up and say angle 4 and angle 2 add up to 180, and we don't know that for sure. Is angle 4 anything to angle 1, 2, or 3? Nah, it's on a completely different vertex. We can't really say a whole lot about that. Other questions? Make sure binders, make sure you're getting them ready. Don't wait till the last minute. Get that started today, maybe day during the intervention. I ask questions about it. All right, go ahead and copy this down, this next set of notes. I think we talked last time about if Curtis has no notes up till now, he's going to have this set, the last set, next time set, at least 4. I think we talked about it a couple times. I know, but Curtis, we're all worried that you're not going to be able to find them. Well, those of us who, those of us who care, Curtis, are
There's gotta be
worried.
some notes in there.
Start writing. I just put pictures up here for a paragraph proof and a flow proof. You can draw whatever you want for each one.
Are we done with this good for today?
No, probably not. Well, probably set it down here. Make it easier to write. So a flow proof or a flow chart proof, we're not going to do any of these, but I wanted you to see what they look like. You should still be able to read them. Notice on this flow proof, you put your statements in the box, and what goes right below the box? The reason. And that's all it is, all the way through. So it's the same as a 2-column proof, you're just writing it as a flow chart or a flow proof instead. It just seems like too much to even worry about. I'll let the English teachers and social studies teachers handle you guys doing flow charts or flow proofs. A paragraph proof, what do you think a paragraph proof is? Just a paragraph. So on this one, and look, this looks like my writing because it's horrible. Given states, I probably should say the given states, right? The given states that B is the midpoint of segment AC, therefore AB is congruent to BC by the definition of a midpoint. Since BC is congruent to DE, we can conclude that AB is congruent to DE because of congruency of segments, transitive property. It should say transitive property written out there. I don't know, that's one I just copied it offline. I didn't even read it, just copied what that's probably something that some student had written down at some point.
That's plagiarism.
Please write that down.
I wouldn't write the whole thing down. I'd write something like paragraph proof uses a paragraph to prove something or something like that. What happens when I open up the door and I set you outside and have to look through the door to take down the
What?
because that's what I'm getting ready to do. And you can be funny out there in the hallway all by yourself all you want.
All right.
Alright, now a bunch of theorems and postulates. First one, this is a pretty easy one. Again, they give these theorems and postulates names and stuff, and some of them will give them names. Don't tell me the name or the number, because I don't have a clue. Like the 2-point postulates. Anybody remember what the 2-point postulate said?
2 points in a line.
Which one is it? Is it 2 points make a line, or is it a line always has at least 2 points?
2 points make a line.
Is that the one?
Yeah.
I don't know either. See,
I know 2 points make a line, so.
Hunter, I think Evan's making up stuff, just trying to act confident.
Okay.
Don't tell me the name of it. Evan, don't look it up. Evan, you are correct. I'll tell you that.
That's what I thought.
Just gotta say it's like
Don't tell me the name of them, and that's part of the problem I'm having because they give me tests that I could just give to you, but I don't like the fact that they write as their answer, they'll write theorem 2.3. There's none of you should memorize what theorem 2.3 says, all right? What you should memorize is what do we know about all right angles? They're congruent. So if we have 2 right angles, what can you say about them?
They're congruent.
They're congruent to each other. Seems like a postulate, doesn't it? Seems like a postulate because it's something that you just sort of take it for granted is true. But I guess since we'd have to say that they're congruent, if we had 2 angles, like if we had angle A, let's do it this way. If we had angle A and we had angle B, and you wanted to say that those 2 are congruent to each other, first thing we're going to say is this one's a right angle, that one's a right angle. Well, to say that they're congruent, and that's sort of, that's given to us, right? Sort of. To say that they're congruent, we need to say, what's congruent mean again? 2 words. Same measure. So we'd have to tell each one's measure. Well, what's the measure of angle A? 90. What's the measure of angle B?
90.
Now what can we say about both of them?
They're both the same measures.
They're both the same measure, so they are congruent. So that's why it sort of takes a step to get to that. I think you're right though, I think it should, you know, if it was a postulate, probably wouldn't throw a big fit about it. Alright, write this one down, these next two, very, very, very important. So Lexi's gonna make sure she gets up and writes these two down and writes down the example there because we're gonna talk about the example. You gotta know how to use these. Guarantee there's gonna be a couple of these on the test where you use this theorem. Something what you know. All right.
Do you have a favorite football team?
National Tree.
Why would you, what? How would that be your favorite football team?
Alright, short form. I don't know if this book uses this short form or not, but this is what I'm going to use. Alright, I couldn't find anywhere in this book where they actually shorten it up. They want you to write out this big long thing and it seems sort of ridiculous. Angles supplementary to the same angle are congruent. Alright, so if I gave you 3 angles here, if I just made up a picture here. We got angle 1,
45 degrees.
we got angle 2, and we got angle 3. If I tell you 2 and 3 are supplementary, what's that mean to be supplementary? They add up to 180. And I tell you 1 and 2 are supplementary. Again, what's that mean? They add up to 180. What has to be true about 1 and 3? They have to be. Sorry, because I'm telling you, I'm sitting home. If I gotta treat you like you're 5 again and not turn my back on you, then Right. What's that tell you about 1 and 3? They have to be the same, right? Let's make up a number here. Give me a number for angle 2.
115.
Give me something easy.
120.
120. If it's 120, what's angle 3 got to be?
60.
60. What's angle 2 got, or angle 1 got to be?
60.
What do you notice about angle 1 and angle 3?
1 and 3 are congruent.
They got to be the same. No matter what, they have to be the same. So if 2 angles are supplementary to the same angle, these 2 angles, 1 and 3, are both supplementary to angle 2, then those 2 angles have to be congruent. They have to be the same. And then the second part of it says, angles supplementary to congruent angles must be congruent. So if I gave you another angle like this, we'll call it angle 4, and I told you angle 2 and angle 4 were congruent. Let's get rid of these numbers. They're no longer there. If 2 and 4 are congruent to each other, and I told you that 1 and 2 are supplementary, and 3 or 4 are supplementary, well, what's that going to tell you about 1 and 3? Again, they have to be congruent to each other. If they're supplementary to 2 angles that are congruent to each other, then they have to be the same. Alright, so looking down here, angle 1 is supplementary to angle 3. Forget all my pictures up here because I don't know if it fits it or not. So forget all that. Erase it. If angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 3, then what can we say? What if 1 supplementary to 3, notice you got angle 3 right here, 2 supplementary to 3. Angle 1 has to be congruent to angle 2. Those 2 have to be congruent. Angle 1 is supplementary to angle 3, angle 2 is supplementary to angle 4, and 3 and 4 are congruent to each other. Well, what's that tell us about 1 and 2? They're congruent to each other also. If these 2 add up to 180, these 2 add up to 180, and 3 and 4 are the same, then that means 1 and 2 have to be the same. All right, write this down, even though Curtis thinks it didn't change.
I did.
What's different about this one?
Complementary angles.
It's complementary instead of supplementary. Same idea, it's just complementary instead of supplementary. Again, don't remember the number. Angles complementary to the same angle are congruent. And then the other short form, if angles are complementary to congruent angles, then they must be congruent. So looking down here, if angle 1's complementary to angle 3, angle 2's complementary to angle 3, what's that tell you about 1 and 2?
Congruent.
They gotta be congruent. So angle 1 would have to be congruent to angle 2. If 3 and 4 are congruent to each other, and 1's complementary to 3 and 2's complementary to 4, what's that tell you about 1 and 2? Same thing, they gotta be congruent to each other. Austin, all that makes sense? Nothing really hard about those, just gotta put a little thought into it sometimes, right? Gets a little confusing. Alright, write this one down. Postulate 2.8. And I actually put two forms of this. Again, don't remember postulate 2.8. So these are both postulate 2.8, but don't remember it by its number, just these are just reasons that you could use.
What if we do remember? You think we're cheating?
Do what?
Like if we remember, if you think we cheat?
Nah. I just won't have any idea.
I get pretty suspicious back there.
So Evan, if you write down postulate 2.8, I won't look it up or anything. I won't know if you cheated or not because I just marked it wrong because I don't have any idea what postulate 2.8 says. I do know that two angles that form a linear pair though must be supplementary. Two angles that form a linear pair must add up to 180. I know those two things. I just don't know that that's 2.8. Unless you're Sheldon and have an identical memory, then probably not going to memorize 2.8 and 2.9 and 1.5. What is a linear pair again?
At 180 degrees, they're the same.
Alright, so we got this line here. What can you tell me about those two angles? They're supplementary. They're a linear pair, so they have to be supplementary. We also know they're a linear pair, so they have to add up to 180. That's something that we sort of learned before. They just wanted to write it as a rule. Alright, I think this is the last one. Maybe. Theorem 2.6. We talked about this theorem earlier this year, but now again they're giving it to you formally. Shortest theorem in the book, most useful theorem in the book also. What do you know about vertical angles? They're congruent. They gotta be the same. Anytime you have two lines that intersect, how many pairs of vertical angles do you have? Two. Name me the vertical angles in the picture I just drew up here.
6 and 8, 5 and 6.
6 and 8, 5 and 7. What do you know about 5 and 6?
They're similar.
They're supplementary. 5 and 7,
Vertical.
they're vertical, so they have to be congruent, so on, so on, so on. Guarantee there's a few of these problems on the test. If I tell you the measure of angle 2 is 110, so that angle right there is 110 degrees. What other angles can you tell me? 3 is 110 degrees.
1 is 70. 4 is 70.
Measure of angle 1 is 70 degrees, because they have to add up to 180. And the measure of angle 4 is also 70 degrees. Anytime I give you a picture, it looks like this, and I give you one of the angles, you should be able to find the other three. If I go back to this picture, Guarantee there's like 3 or 4 problems like this on the test. Go back, tell you angle 2 is 10x minus 4. So I'm gonna write that in there. 10x minus 4. Angle 3 is 6 times x plus 2. What can you do with those 2 expressions?
Substitute.
What kind of equation can you use? How could you set up an equation?
Come together.
How?
10x minus 4 equals 6, or these x plus 2. Are you sure we did it?
Alright, now, before we go any farther, there'll be problems like this on the test. Then there's gonna be another problem that maybe doesn't give you that. Maybe they give you this over here.
So you just add them together, equal 180.
Now that one, we'd add them together and set it equal to 180. You gotta make sure you know which equation you're using, alright? Sometimes you set them equal to each other. Sometimes you add them together and they equal 180. So we do this, you said distribute 6x plus 12 equals 10x minus 4. What's next?
Subtract 6.
Subtract 6x on both sides. What's that leave us with?
4x minus 4
Equals,
12.
add 4 to both sides. What's that leave you with?
16.
Divide by 4. What's x?
X plus 4.
Is that our answer?
Yeah. No. You gotta find the angles.
No, they wanted us to find the angles, right? I need to go back and get that out of there.
You gotta substitute it.
So I take that 4 and I substitute it in. It doesn't matter really which one we put it into. Neither one of these are real hard. If I put it in up top here, what's 10 times 4?
40.
40 minus 4?
36.
That angle's 36 degrees. What's angle 3 down here?
36 degrees.
36 degrees. How could we find angle 1?
You just take 180 minus 36.
Those two had to add up to 180, right? So 180 minus 36, what's that, 144? Is that right? What's angle 4 over here?
144. But if you do the 6x plus 10 equals 4, it's only 22. I mean 26.
Yeah, that's right.
So then we did something wrong. No, it's not.
6.
What's 4 plus 2?
You have to distribute it though.
No, you don't. Not once you know all the numbers. But even if we
6
do
times
this,
4 plus.
what do you do first then?
Oh, okay, you're right, you're right.
What do you
I
do
didn't
first
it.
on
I
that
didn't
problem?
Times it by 2.
What do you do first on that problem? You add them together, don't you? Do what's inside the parentheses. Now, even if you do distributed property first, what's 6 times 4? Then you gotta do 6 times 2, what's that?
12.
What's 24 plus 12?
36.
Is that the same thing we got?
Yep.
Please don't do it this way, because you're gonna do what Evan just did there and mess it up.
Yeah.
What should you do first on that problem? Add first, do what's in the parentheses, that's what the PEMDAS means, right? What's P stand for? Parentheses, you do that first.
Addition, multiplication, division.
And that worksheet I forgot. Didn't work.
We always have.
Put this in your notes with today's notes. So maybe, like if Austin's not sticking it in his binder right now, could he put today's title on it so he knows what it goes with?
Yeah.
What was today's title?
Posture right there.
More proofs.
Yeah.
More proofs. So put it in there so that you have it in there. You're gonna fill it in. Put it on the other one too.
What?
Put it on the other one too.
Oh, that's that one. Oh, the other side?
No, on that.
I did.
looking at the top here, fill it in. You're going to go down through and fill it in. The first 6 problems. If you don't have this filled in, then you're only going to get half credit for your notes for today. The first 6 problems says 2 lines that are not perpendicular intersect such that angle 1 and angle 2 are a linear pair. So let's stop right there. Somebody come up and draw this first part for me. What's it say? 2 lines that are not what? Perpendicular intersect. So what do we need to draw?
Supplementary angles.
Sort of, but what do we need to draw? Just 2 what?
2 lines.
2 lines. Somebody go draw.
Gotcha. Where's this mark at?
Right up there.
Her name? What's her name?
And
Yeah. I don't know her name.
Does everybody agree with that, what he's got so far?
Curtis.
Except, what didn't he make it? He didn't make his full line, did he? So it needs to come on down. Probably should extend this on out, because are we gonna get confused by that? If it's all that real close? So we got, that's not there, that's not there. Angle 1 and angle 2, what's the next part say? Angle 1 and angle 4 are a linear pair. Where's angle 4 gonna be at? Got 2 more spots, which one?
On the bottom.
It's on the bottom, that's good.
One.
It's right under 2.
left.
But it's right.
Left or right?
Right.
Left.
Left?
It would be on the right, because on the right, be vertical angles.
So it's over here, because they said 1 and 4 together are a linear pair. Do those 2 together make a line? Then it says angle 1 and angle 3 are vertical angles. Where's angle 3 going in?
On the right.
So we have that picture. Now you're just going to answer true or false for each one of these. So just write F or T in there. Angle 1 is congruent to angle 2. True or false?
True.
Oh, yeah.
True?
Yep. False.
Uh-huh. Just kidding.
Angle 1 and angle 2. They congruent? It's false. They're not congruent to each other. What are they to each other?
Supplementary angles.
Supplementary. Number 2, make sure you're going straight across, looking at number 2. Angle 1 and angle 3 are congruent.
Yeah.
How come?
Because the vertical.
They're vertical angles, so that one's true. So number 2 is true. Number 3, angle 1 and angle 4 are congruent.
True. They're linear pairs.
So they're congruent.
False.
False, Kenneth says.
False.
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 It's false. Number 4, angle 3 and angle 2 are congruent.
True.
Look at angle 3 and angle 2. Are they congruent?
False.
That's
False. Number 5, angle 2 and angle 4 are congruent.
True.
Those are vertical angles, right?
Yeah.
And number 6, measure of angle 3 plus the measure of angle 4 equals 180.
Yeah.
Those 2 add up to 180?
Yeah.
So that's true.
Right.
Wow.
All right, look at number 7. Number 7 there. We're going to do number 7 together. Is it going to be helpful for Bree to have number 7 written down in her notes?
Yep.
So she's got an example of a good 2-column proof. So we got this diagram. Give me a second to get the diagram stuff drawn. They tell us, what's that upside down T mean?
Perpendicular.
Perpendicular. So segment AB is perpendicular to segment BD. So what's that tell you? How they intersect. So what can I put in here?
Square.
A little box, right? So somewhere, what angle, somewhere in our two column proof, we're gonna say that what angle is a right angle? ABD is a right angle. So I'm just gonna make some notes here for myself. Angle ABD is a right angle. Somewhere in our two column proof, we're gonna have to put that. Then they tell us ED is perpendicular to DB or BD. So what's that tell us about what angle?
Right angle.
What's the right angle?
EDB.
EBD.
Say it again.
EDB.
EDB, go back.
EDB is a right angle. Somewhere in our two column proof, we're gonna have to put that. Then they tell us angle ABC. ABC is this angle. I couldn't quit doing that. Angle ABC is congruent to angle EDC.
Yes.
So that means these two angles are
Congruent.
congruent to each other, so they're the same. What can you tell me about this angle and this angle? They're complementary, so somewhere we're gonna have to put in our two column proof that you have these two complementary angles, right? What can you tell me about these two angles?
They're complementary.
So we're gonna have to do that twice, aren't we? We'll have to put it in there twice. Well, if these two are complementary, these two are complementary, this one is congruent to that one, what can you tell me about this angle and this angle?
Vertical.
They gotta be congruent to each other, right? Now, are they vertical angles?
No, I'm gonna say congruent.
They're congruent to each other, right? Because that theorem that we just had that said if two angles are complementary to congruent angles, then they have to be congruent. So we should be able to write this two column proof. And I'm gonna be lazy. What's that S stand for? What's the first thing you're gonna write down?
Angle CBD.
Where do you start at?
Angle AB.
Angle AB?
Oh, yeah.
Line AB.
What is it? It's not a line. Segment AB is perpendicular to segment BD. How do we know that?
Good.
It was given to us. Once you know that those two segments are perpendicular, what did that tell us? It's a right angle. What's a right angle? ABD, right? So we put that angle ABD is, it's alright if I abbreviate right RT? Does everybody understand that? ABD is a right angle. How did you know that that was a right angle?
It's given.
Was it given to you?
No, it just tells you the perpendicular thing.
Perpendicular, and that's what you're gonna write. Perpendicular lines form what kind of angles?
Right.
Right angles. Perpendicular lines form right angles. That's the definition of perpendicular. Perpendicular lines form right angles. Can we say more about that being a right angle right now? No. So where do we go to next? The second given. What was the second given?
ED is perpendicular to BD.
So you guys are getting the hang of this. If you just use some common sense and work your way through, right? Just don't let yourself get lost. ED is perpendicular to segment BD. How do we know that? Given. Once we knew that this segment was perpendicular to this segment, what did we say? What's a right angle? EDB. So angle EDB is a right angle. How'd you know it was a right angle?
Perpendicular thing.
Perpendicular lines form
At angles.
right angles. Tell me you have perpendicular lines, they form right angles. Now we know that both these are right angles. Could we say that they're congruent to each other? Yeah, we could. Is it gonna help us with the way that we had it thought out? No. We could, and there's other ways, more than one way you could actually prove what we're trying to prove, and that would lead us to other ways of doing it, but the way we said to do it is a little different than that, so we don't need to say that they are. What's the next thing we said? Maybe the third given? What was the third given? Angle ABC, is that right? Yeah. Is congruent So clear down here in statement 5, we're still using some of the given information. You don't have to put them all right up there at the beginning. Now, what else did we say? What'd you guys tell me about these two angles?
Complementary.
They're complementary, so we're gonna say that. Name those two angles.
ABD and ABC.
Be careful now.
ABC.
ABC
ABD.
and CB,
Oh, CBD.
CBD. So angle ABC, I'm gonna shorten this up a whole bunch. Just put ABC's comp to, what's the other angle?
CBD.
CBD. How'd you know that those were complementary? Two angles together add up to a right angle, right? And all on my right, comp angles add to a right angle. Add up to a right angle. Or 90 degrees, I would accept there also. They add up to 90 degrees. What other pair of angles do we know are complementary?
EDC and CBD.
Angle EDC is complementary to what other one? EDC is complementary to what? CDB. How do we know that? Same thing, right? Comp angles add to a right angle. We finished yet? Look at what we have here. You had angle ABC is congruent to angle EDC. Do you see those same things right there? Well, if these two are congruent and they're complementary to these two, what's that tell you about those two? They have to be congruent. CBD is congruent to angle CDB. And we just had that theorem, right? Somebody tell me the shortened form, I don't remember. What was it in your notes there? Comps of
Congruency.
that was one of the terms we just wrote down.
Angles complementary to the same angle of congruent.
Bottom one, because we said, we didn't say they were complementary to the same one.
Angles complementary to congruent angles are congruent.
Now I gotta erase this because I started to write it wrong. So that's what you're gonna write on that line. Angles, comp to congruent angles are congruent. How many points would this be worth on the test?
So
16. It's worth 16 points.
I have 6 right now. I shortened it up.
That won't work.
What?
Because I'm gonna make it worth 16 points, and if you don't have them written down there, you're gonna miss some of them.
Well, I guess I missed 4 points.
How many points should you most definitely be able to get on this? 8. Should you be able to get this one?
Yeah.
Should be able to get that one,
Yep.
Well, you're,
this one, that's 4, this one, that's 6. Should you be able to get this one?
yeah.
Yeah, that's what you were trying to prove, right? Maybe you missed the reason for trying to prove, but should you miss the statement? No. So we got how many points? So you got 7 out of 16 already. That's not good, but it's better than 0, isn't it? My bad. Should you be able to get some of these others? Like, should you be able to tell that, hey, if I have perpendicular lines, that's got to be a right angle?
Yep.
All right, flip to the back page, back side. On the back side, we're going to answer these questions. All right angles are
Congruent.
congruent. Do you see congruent in there anywhere? Put congruent in that line. So for A, the blank should say congruent. What's gonna go in box A up there then?
Right angle, no, straight angle.
What goes in box A? Look,
Oh, congruent.
you write congruent up here. You look at the boxes and what they do. Where do you see congruent at? Make. So write make up there in box A.
Why?
Because that's what they're saying. They say complete each exercise, find the answer in the answer column, write the word under the answer in the box containing the exercise letter. So you're going up, so you're coming
Oh,
over
I see,
here.
I see it.
Makes sense now? So, letter B, blank angles form a straight line. Supplementary. Supplementary angles form a, and why they say a straight line there makes me mad, because what do you know about all lines?
They're straight.
All lines are straight. They shouldn't say straight line, they should say straight what? Angle. Straight angle. So somebody's messed up. What word goes with supplementary?
Here.
Sure. So in box B up there, what do you write? Sure. Somebody help Curtis out because he didn't write that in box A. What goes in box A?
Sure. Make.
Make. Because right there's the answer. So you write the word underneath it in there. What goes in box B?
Sure.
Sure. Letter C, if two angles form a blank, then they are supplementary.
Linear pair.
Linear pair, good. Linear pair. What word goes up in box C?
Line.
Everybody agree with that? Anybody read the question? What was the question before we get the answer?
How can you make sure?
How can you make sure you can start a fire with 2 sticks? Letter D. When 2 lines intersect, the blank angles are congruent. What kind of angles when you have 2 lines that intersect?
Horizontal.
You have 2 lines. Where did that even come from?
I don't know.
There's
I'm
something.
just looking at words.
What angles on there do you know are congruent? The vertical, horizontal. We don't have horizontal angles. You have vertical angles. That's what it is, and he's always copying on that.
Who says that?
I did.
You can't copy if nobody's around you.
I said you're copied off Hunter.
Vertical, what line or what word goes up in box D? Of. Everybody agree with that? Of. That's vertical. And of goes up in the box. Letter E. Could we find all those angles? I got the picture drawn up here now. 4, 1, 2, 3. They tell us that angle 1 is 67 degrees. What other angle do you know? 3 is 67. Grab your calculator.
Oh, it's 113.
113, everybody agree with that? What's angle 4 then?
113.
So for angle 2 is 113 degrees. What box goes in letter E then? Then? Is it them? Them? And measure of angle 3, what was the measure of angle 3?
67.
67, what box goes in letter F up there then?
Is. Make sure one of them is.
Now we're on the second line, right? Letter G, watch closely because I guarantee there's some of these on the test. You gotta be able to set up these equations. This is x plus y. This is 2x. This is x plus 60. And this is y plus 20. Now there's about 1,000 different equations you could set up here. So Lexi's gonna make sure that she doesn't mess this up. Because you want to set up the equation that's the easiest, right? Whatever's the easiest. Could I say that this equals this angle? Yeah, but watch what happens. So I got 2x equals y plus 20.
You don't have a y.
Can you solve that? No, because it's got two different variables in it. So when we set up the equation for this, we want to make it so it's an easy equation. Anybody see anything that might be easy? So if I do x plus y, what do I know about it? It equals what?
X plus 60.
X plus 60. Maybe. That one actually works. That's not the one I'd set up, but if you set that up, what's the first thing you do?
Subtract an x.
Subtract x on both sides. Well, when you subtract the x on both sides, what's going to happen to the x?
Y equals 60.
They're going to cancel out, aren't they? So that would work. The one I would have set up, what do you know about these two angles?
Says, they add up to 180.
They add up to 180. Very good. Now, is that an equation I can solve?
Yeah.
3x plus 60 equals 180.
Subtract 60.
Subtract 60 on both sides, you get 3x equals
30. I mean, 120.
120.
Divide by 30.
Divide by 3.
40.
So x equals 40. What did they ask us to find? Just x?
Yeah. And y.
So x and y. So x equals 40. What answer is that going to put up here? A. So put A in box G. How are we going to find y if we know x equals 40?
Do x plus y.
Could we go right back up here and plug it in here anywhere? Yeah, if x equals 40, how much is this angle right here?
60.
80, right? So what's this right here got to equal? 80. Well, what's y got to equal then?
80. Oh, 60.
60. Is that one of the answers on there? Match? So put match up there in box H. Did that answer the question that they asked us?
Make sure one of them is a match.
What was in G? Curtis missed it.
A. Put your A.
Alright, write this down, this your assignment. On number 18 it says, write a flow proof. Don't. Just do what else it says, but don't write a flow proof. 19, it says also write a 2-column proof. Don't. I think 19 they want you to finish out the paragraph proof just by filling in the blanks. And 18 they want you to finish out the 2-column proof by filling in the blanks. That's all I want you to do on those two. I don't want you to do the extra where it tells you to do something after you get done with what's on the page.